The production of large-size roller bearings involves several precise steps using advanced machinery and systems. Initially, high-quality steel is selected, which is then heat-treated to achieve the desired hardness. The steel undergoes forging or machining processes to form the inner and outer rings of the bearing, followed by the production of the rollers. A cage is also fabricated to separate the rollers, ensuring smooth rotation. These components are assembled using automated systems, which streamline the process and ensure precision. Throughout the production, modern CNC machines are used to achieve high accuracy in dimensions. Each component is inspected thoroughly through various quality control measures, such as dimensional checks and material testing, to meet strict industry standards. The entire system is designed for efficiency, allowing the production of bearings capable of withstanding heavy loads and high speeds. Once assembled, the bearings are packaged and shipped, ensuring they meet the durability and performance requirements for demanding industrial applications. The CNC steel pipe bending machine with hole punching integrates two critical processes, bending and hole punching. First, raw pipes are loaded into the machine and the bending parameters are programmed. The machine bends the pipe using hydraulic or electric actuators while simultaneously punching holes at specific locations. The precision of these actions ensures that the product meets exact specifications, reducing material handling and production time for increased efficiency. The production process of saddle-shaped panels involves several key steps, starting with raw material preparation. High-quality galvanized steel sheets are selected, along with insulation materials like EPS foam, fiberglass, or other composite substances. The sheets are then processed using cutting and bending machines to shape them into the saddle form. Afterward, adhesive is applied to the surface of the sheets to ensure a strong bond between the layers. Next, the insulation layer is placed between the two metal sheets to create a sandwich structure. This sandwich is then subjected to pressure in a pressing machine or autoclave to ensure the layers bond together effectively, forming a solid panel. Once bonded, the panel is cut to the required size. Final steps include quality checks to ensure strength and durability, as well as surface finishing, such as coating for aesthetics or additional protection. The entire process uses advanced machinery, ensuring high precision and efficient production. The hot forging press line 12,500 tons is a high-capacity industrial system designed to shape metal components through hot forging. The process begins with loading raw metal billets into the press. At high temperatures, the press uses immense force to shape the metal into desired forms. The metal's reduced hardness at elevated temperatures makes it easier to deform, allowing for complex shapes and sizes. The press operates at a high pressure, exerting up to 12,500 tons of force to ensure the precision of the formed parts. After forging, the components are subjected to cooling, machining, and quality inspections to ensure they meet exact specifications. This line is crucial for producing large-scale, durable metal components for industries like automotive, aerospace, and heavy machinery. The advanced systems and automation within the line ensure efficiency, precision, and consistent quality in the production of these forged parts. The overall process is streamlined to deliver high-quality products while maintaining safety standards and optimal production times. The production process starts with creating an exact wax pattern, injected into a mold. The wax pattern is assembled onto a wax feeder system and dipped into a high-grade ceramic slurry using a robot. Larger ceramic particles are added to the wet slurry to build a thick coating. This investment process is repeated to form a sturdy shell mold. Once the shell is dried, the wax is melted out in a steam autoclave, hence the term lost wax process. The mold is then fired at over 1,000 degrees Celsius to remove any residual wax and strengthen the shell. After cooling, molten metal is poured into the mold, filling the thin sections. Once cooled, the ceramic shell is broken away, and castings are cleaned, heat-treated, and tested, including X-ray and machining if necessary. The production process at Florida Smith Mag Gear is designed to deliver high-quality, heavy-duty gears for industries like minerals and cement. Established in 1913, the company is a leader in gear manufacturing with facilities in Switzerland, Poland, and Italy. The process begins with detailed planning and precise calculations by specialists, who ensure the gears meet the highest standards. The company's focus on innovation stems from the pioneering work of Max Mag, who revolutionized gear calculation. Once raw materials are selected, they undergo rigorous testing before entering the manufacturing process. One of the key innovations in this process is the gear shaper, developed by Max Mag and still used globally. The SH450 is a prime example of their technology, retrofitted with advanced CNC control systems to handle any gear geometry modification. The company also uses an extensive range of hobbing equipment to ensure efficient production of various gear types. Florida Smith Mag Gear utilizes state-of-the-art machines, such as the Klingelberg GMC 160, which can handle workpieces up to 2 meters in diameter and pinion shafts up to 2 meters long. These machines are capable of cutting spiral bevel gears with precision. For other bevel gear geometries and straight screws, CNC-controlled machines like the 6-axis Depot Expert 5 are used to mill up to 2.5 meters in diameter. After the cutting process, the gears undergo heat treatments, including carbonizing, tempering, and quenching. These processes enhance the gear's hardness and durability for heavy-duty use. The heat-treated components are then subject to hard cutting using advanced CNC-controlled machines, which ensure precise cyclopalloid bevel gears. Throughout production, every component is rigorously inspected using mobile equipment for pitch and profile measuring. Once manufactured, the gears undergo final assembly and are tested to ensure they meet all safety standards. The company's focus on customer satisfaction is evident in their commitment to high-quality products and reliable service. Hanshin Internal Combustion Engine Manufacturing specializes in manufacturing crankshafts for marine engines. The production process begins with the preparation of high-quality steel, which is carefully inspected for its chemical composition and mechanical properties before being used. The steel is then cut and roughly shaped using advanced CNC machines, forming the basic structure of the crankshaft. Next, the crankshaft undergoes precise machining through turning and milling processes on CNC machines. This step ensures the crankshaft achieves the correct dimensions and geometry. Drilling and reaming operations follow to create accurate holes and smooth surfaces essential for the engine's functionality. The crankshaft is then polished to achieve a smooth finish, especially on critical contact surfaces. Afterward, the crankshaft is subjected to heat treatment processes, such as quenching and tempering, to improve its hardness and resistance to wear. These treatments ensure the crankshaft is durable and capable of withstanding the demanding conditions of marine engines. The final stage involves stringent quality control checks, including dimensional measurements and material inspections, to confirm that the crankshaft meets all technical standards. Throughout the entire process, state-of-the-art machinery, including CNC turning, milling, and grinding machines, plays a crucial role. Skilled operators monitor every step, ensuring high-quality production and consistent performance. This combination of cutting-edge technology and expert craftsmanship ensures that each crankshaft is ready for assembly into marine engines, meeting the highest industry standards. The production process of a Kaplan turbine involves several stages. First, 3D engineering simulations are used to optimize the design, focusing on efficiency and durability. CNC machining is employed to precisely fabricate components based on these designs. The parts are then welded and assembled to form the turbine. After assembly, thorough testing ensures performance meets the required specifications. Finally, the turbine is installed in the hydroelectric plant, where regular maintenance is performed to ensure its continued operation and efficiency. Andritz Hydro Norway specializes in providing high-quality electromechanical equipment for hydropower plants. The process begins with advanced 3D engineering simulations to design customized turbines and related components. Skilled technicians use precision CNC machines to manufacture turbine parts, ensuring exact specifications. After manufacturing, components are carefully assembled and tested to meet international performance standards. The company also provides installation services, overseeing the integration of turbines and systems at hydropower sites. Regular maintenance and upgrade services are offered to ensure continued efficiency and longevity of existing installations. This comprehensive process combines cutting-edge technology, expert craftsmanship, and dedicated support, making Andritz Hydro a leader in hydropower solutions. The plate rolling process starts with selecting the appropriate raw material, ensuring its quality and dimensions. The metal is then fed into the rolling machine, which uses rollers to compress and shape the material into the desired thickness and width. This process involves multiple passes, adjusting pressure and speed. After rolling, the plates are cut to specified dimensions, and their surfaces are treated as needed, such as polishing or coating. Final quality checks ensure the plates meet the required standards before being packed and shipped, involving both automated systems and manual supervision. 11. The D52 ring rolling machine is a crucial piece of equipment used in the production of high-precision rings, typically for industries such as aerospace, automotive, and heavy machinery manufacturing. The process begins with selecting a metal billet or preformed ring, which is carefully inspected to ensure it meets the necessary standards for size and quality. The billet is then placed into the D52 machine, which is equipped with an advanced programmable logic controller (PLC). This system allows precise control over parameters such as the ring's diameter, wall thickness, and the rolling force required. The billet is positioned between the machine's rollers, where the transformation into the desired ring shape occurs. The rollers exert significant pressure on the material, gradually shaping it as it moves through the machine. The rolling process on the D52 machine is multi-stage, where each stage adds incremental changes to the material's shape. The hydraulic system plays a key role in applying consistent pressure to ensure the formation of uniform rings. During the rolling operation, the machine continuously monitors parameters such as force, speed, and temperature, ensuring optimal shaping and preventing defects. Once the ring is formed, it often undergoes further processing steps like heat treatment or grinding to enhance its mechanical properties or improve surface finish. The machine's high precision ensures that the final product meets stringent industry standards. Quality control checks are performed at each step of the process, with advanced measuring techniques used to inspect the dimensions and surface finish of the ring. After the final inspection, the rings are cleaned, coated for protection, and prepared for shipment. The D52 ring rolling machine ensures the consistent production of high-quality rings, contributing to the durability and reliability of components used in critical applications. 12. The production process involves the use of a ferrule open-side boring mill and a Giddings and Lewis vertical turning center. The turning center is set up to handle gears ranging from 0 to 20 feet in diameter, with flexibility to accommodate larger sizes up to 50 feet. The machine features live spindles enabling drilling, tapping, and milling during the turning process. This integration allows for continuous machining. The open-side boring mill handles additional operations like drilling and tapping, while the gear remains mounted. With pallet changers for quick setup, the system ensures high efficiency and accuracy throughout the gear manufacturing process. The Francis turbine production process involves several steps. First, components such as the runner, guide vanes, and shaft are designed based on project specifications. These parts are fabricated using advanced machinery, including CNC machines, to ensure precision. After fabrication, the components are assembled with attention to alignment and functionality. The completed turbine undergoes rigorous testing for water tightness, vibration, and load-bearing capacity. Once tested, the turbine is transported to the installation site where it is set up and connected to the generator, ready for operation in hydroelectric plants. The casting process involves several stages, starting with the creation of a mold, typically from sand or metal. Molten metal is poured into the mold, where it cools and solidifies. After cooling, the mold is removed, and the casting undergoes finishing processes such as grinding, polishing, and quality checks. This method is essential for producing parts used in industries like automotive and aerospace, ensuring precision and durability. Sanhei Kitchen specializes in producing high-quality tri-ply stainless steel cookware. The production process begins with precise design and mold creation. Stainless steel sheets are cut and treated to ensure durability and heat conductivity. These sheets are then stamped and shaped using hydraulic presses. The layers of steel are welded together with advanced technology, ensuring strong bonds. CNC machines are used for precise finishing, followed by polishing and surface treatment for a sleek, corrosion-resistant finish. Each product undergoes strict quality control tests for strength, heat conductivity, and safety before packaging and shipment. The production process in open-pit mining, specifically at the Hambach site in Germany, is a highly coordinated and technical operation, primarily carried out by the BG 290 bucket wheel excavator. This giant piece of equipment works continuously to extract brown coal, a vital resource for power generation. The excavator, designed for massive workloads, operates in one of the world's largest and deepest open-pit mines, spanning over 8,500 hectares. The primary task of the BG290 is to dig through the sandy ground, removing overburden and extracting coal at a rate of 40 million tons per year. The excavator's operation is controlled by a sophisticated hydraulic system and a highly specialized steering mechanism. The BG290 is mounted on 3 crawler bases, each consisting of 4 crawler units, ensuring the distribution of its enormous 13,500-ton weight. The movement of the excavator is controlled by a hydraulic steering system with a large 30-ton hydraulic cylinder that enables precise navigation through rough terrain. This hydraulic system is powered by 4 piston pumps, delivering a combined 500 liters of hydraulic fluid per minute to the system. Regular maintenance is crucial to ensure the excavator's smooth operation, given the harsh mining conditions. The cylinder, which is a key component, undergoes routine checks and, when necessary, reconditioning due to the abrasive wear it faces. Over the years, the piston rod in particular experiences significant damage from falling stones and the heavy loads it supports. In 2005, the RWE Power Company had to seek external expertise to carry out reconditioning work on the 40-ton hydraulic cylinder. The reconditioning process is extensive, requiring the disassembly and inspection of the cylinder, piston rod, and other components. The cylinder is sent for resurfacing, including the replacement of sealing elements, honing of the cylinder tube, and repairing of any damage. The piston rod is meticulously reconditioned with a chrome nickel coating to restore its integrity. Throughout the reconditioning period, the tight schedule is maintained to minimize downtime, with the entire repair process completed in just 21 days. The efficiency and precision of the machinery, combined with the continuous maintenance efforts, ensure that the excavator remains operational, maintaining the constant flow of coal extraction and supporting power generation. The entire system relies on seamless collaboration between advanced machinery, specialized components, and skilled technicians to ensure uninterrupted production. The LADA press production facility begins with the preparation of raw materials, primarily metal sheets, which are cut to precise dimensions. These sheets are then placed into specially designed molds, ensuring that the components formed will meet exact specifications. Advanced hydraulic stamping presses apply high pressure to the metal sheets, shaping them into vehicle parts such as body panels, doors, and hoods. After stamping, the components are carefully inspected for any defects. Surface treatments are performed to remove contaminants and improve the durability and corrosion resistance of the parts. This includes processes like cleaning, coating, and painting. Each part undergoes rigorous quality control checks to ensure it meets the stringent standards required for automotive manufacturing. The press production line combines automated machinery and skilled operators. The machines are controlled by advanced computer systems, allowing for high precision and efficiency. Operators monitor the process, making adjustments as needed to maintain consistent quality. The stamped components are then transferred to other stages of production, such as welding and assembly. The integration of automation and human expertise allows for fast, efficient production, while ensuring that each part meets the high standards of LADA's automotive products. This seamless workflow supports the creation of high-quality vehicles that are reliable and durable. The production process of large tube bending with SIMASV horizontal bending presses starts with selecting the appropriate tube material and preparing it for bending. The tubes are loaded into the press machine, which is equipped with specialized tools to control the bending radius and angle. The machine applies precise force to bend the tube, ensuring accuracy and consistency. After the bending process, the tubes are inspected for quality, checking the curvature and alignment. Any imperfections are corrected, and the tubes are cleaned and surface treated for a durable, high-quality finish suitable for various applications. The tire retreading process, particularly focusing on the boring stage, involves several key steps. First, used tires are collected and cleaned to remove any dirt or contaminants. Then, the tires are cut into smaller sections for easier handling. In the boring phase, specialized machinery drills precise holes into the tire surface, ensuring optimal conditions for further processing. This step aids in the separation of materials, such as rubber, steel, and fiber. Following the drilling, the tire parts are further processed to extract reusable materials for new products. Quality control is performed at every stage, and the final recycled products are packaged for distribution. Throughout the process, human operators oversee the machines, ensuring smooth and safe operations. while automated systems help streamline production for efficiency. The Surma's 131 high-speed bandsaw is an essential tool in the aluminum industry, designed for cutting aluminum billets into precise lengths. The process begins by loading billets onto the machine's conveyor system, ensuring proper alignment. Once in position, the high-speed bandsaw operates with precision, making swift and clean cuts to the billets. The saw's design minimizes material waste and ensures smooth edges, crucial for subsequent manufacturing steps. The system is fully automated, reducing manual labor and enhancing operational efficiency. Additionally, the saw includes an integrated dust extraction mechanism that captures debris, keeping the work environment clean and free of obstructions. This automated cutting process is highly reliable, providing consistent results and maintaining high production output, ensuring smooth integration with the rest of the aluminum processing line. The Becce 16 Automation Forging Line, Umuco RW2 by Tomasek Engineering, integrates cutting-edge automation technology for enhanced productivity and precision. The process begins with automated billet feeding, ensuring precise alignment for optimal performance. Once in place, billets are transferred to a hydraulic press or hammer for shaping. Real-time data and sensor feedback control the forging process, maintaining consistent quality and precision. By minimizing human intervention, the automation system streamlines production and boosts throughput. Additionally, the efficient system reduces material waste and energy consumption, making it a cost-effective solution for large-scale forging operations. This advanced line offers high productivity, reduced costs, and superior quality control. ASO Forge specializes in the production of high-quality special steel bars, utilizing advanced machinery and a streamlined process to meet diverse industrial needs. The production begins with the careful selection and inspection of raw steel billets. These billets are then heated in high-temperature furnaces to achieve the necessary malleability for the forging process. Once the billets reach the desired temperature, they are transferred to hydraulic presses or forging hammers, where they undergo shaping under controlled conditions. Automated systems closely monitor the process, adjusting parameters in real time based on sensor feedback to ensure precision and uniformity in every piece. After forging, the steel bars are subjected to heat treatment processes, such as quenching and tempering. This step enhances the mechanical properties, ensuring that the bars achieve the desired hardness and strength. Following heat treatment, the bars are further processed through machining steps, which may include cutting, turning, milling, or drilling to meet the required specifications. Rigorous quality control checks are performed at every stage to verify dimensions, surface finish, and overall integrity. Once quality assurance is complete, the bars are cleaned, coated for corrosion resistance, and carefully packaged for delivery. ASO Forge's advanced production line minimizes material waste, improves energy efficiency, and ensures consistent quality, making it an optimal solution for high-volume forging requirements in industries like automotive, aerospace, and machinery manufacturing. Vulcan Industrial Engineering specializes in machining gearbox housings using advanced CNC machining centers. The process starts with raw material inspection, followed by precise milling, drilling, and tapping. Automated tools and quality control systems ensure high precision, producing reliable gearbox housings for industrial applications. The decoiler straightener feeder system by Coiltech is a critical component of the compact press feeding systems, designed to streamline metal processing in manufacturing environments. The system begins with the decoiler, which unwinds large metal coils and feeds them smoothly into the next stage. The straightener uses a series of precision rollers to remove any curvature or deformation, ensuring the metal is perfectly flat for further processing. The material is then fed into the press feeder, which accurately measures and delivers the required length of metal to the stamping press. This process is fully automated, significantly reducing human intervention and increasing operational efficiency. The system's sensors continuously monitor and adjust the feed rate to maintain precision and prevent material waste. The compact design of the system allows for high-speed operations, which optimizes productivity while maintaining high standards of quality control. The decoiler straightener feeder system is ideal for high-volume manufacturing processes, where speed, accuracy, and reduced waste are key considerations. By ensuring that only the required amount of material is fed into the press, the system minimizes scrap and reduces energy consumption. This results in lower operational costs and higher productivity. Additionally, the system contributes to a safer work environment by automating the material handling process, reducing the risks associated with manual labor. The production of railway components using die forging is a specialized manufacturing process, essential for creating durable and reliable parts for railway systems. The process combines high temperatures, heavy machinery, and precise engineering to transform raw materials into finished components. Step-by-step production process. Preparation of billets. The process begins with preparing billets, typically made from steel, which are heated to high temperatures to make them malleable for shaping. The size and composition of the billet are selected based on the specifications of the component, such as railway axles or wheels. The quality of the material is critical for ensuring the durability of the final product. Heating the billets. The billets are heated in a furnace to temperatures between 1,200 degrees Celsius and 1,300 degrees Celsius. This heating makes the material soft enough to shape without breaking, and also helps optimize the material properties, such as strength and durability for railway applications. Preforming. After heating, the billets are transferred to the forging press for the preforging stage. Here, moderate force is applied to the billet to ensure even material distribution and prepare it for precise shaping. This step also eliminates surface defects from the heating process. Main forging. The billet is then subjected to intense pressure using a large forging press. This pressure forces the billet into a die cavity, shaping it into the desired component form. The forging press applies thousands of tons of pressure to ensure uniform material distribution and achieve the correct geometry and mechanical properties required for the railway part. Trimming and cutting. After forging, excess material or grat is removed from the part. This trimming ensures that the component meets the required dimensional tolerances. If necessary, holes or other features are drilled or punched at this stage. Heat treatment. The component then undergoes heat treatment, such as quenching and tempering, to enhance its mechanical properties. This step is vital for achieving the hardness and toughness needed for components used in the railway system. Final machining. Following heat treatment, the component undergoes final machining, which includes turning, milling, and grinding to achieve precise dimensions and surface finish. Computer-controlled machines ensure accuracy throughout the machining process. Quality control. Quality control checks are implemented at various stages to ensure the components meet strict standards. These checks include visual inspections, dimensional measurements, and non-destructive testing (NDT) methods, such as ultrasonic testing, to detect any internal defects. The GE90 and GE-NX composite fan blades represent a significant leap forward in jet engine technology. Crafted by CFAN, a joint venture between GE Aviation and SNECMA, these blades are handcrafted with precision in San Marcos, Texas. These carbon composite fan blades are designed for the world's most powerful jet engines, delivering incredible thrust, over 127,000 pounds on the GE90, almost 2,000 times the power of early propellers. The production of each fan blade involves over 1,700 pieces of carbon fiber, layered and shaped by hand, then cured and precision machined. After rigorous quality inspections, including CT scanning and ultrasonic testing, these blades are finished with titanium edges and glossy coatings. The process takes about 340 hours, ensuring every blade meets the highest standards of aerodynamic efficiency and durability. These blades are not only a feat of engineering but also a work of art, earning a spot in New York's Museum of Modern Art. With over 30,000 blades produced to date, CFAN continues to lead the way in composite fan blade technology, powering the engines that shape the future of aviation. Their advanced composite materials make them lightweight yet strong, enhancing fuel efficiency and performance. CFAN's commitment to excellence is evident in every blade produced, making them the top choice for the world's most advanced aircraft. As aviation continues to evolve, CFAN remains at the forefront of innovation, ensuring safer, more efficient, and sustainable air travel for years to come. How do you make a tire? Let's dive into the fascinating production process of Mitas tires, where precision meets performance. The journey begins 8,000 kilometers away in rubber plantations, where natural latex is harvested from rubber trees. This latex is then transported to the production plant, where it undergoes stringent testing for quality and physical properties in the laboratory. Once the rubber meets the required standards, it enters the mixing room, where it is combined with various materials like carbon black and sulfur to create different rubber compounds for the tire's inner liner and tread. The tire components, including bead wires, steel cords, and rubber-coated materials, are produced using extruding and calendaring processes. These components are carefully assembled on a tire building drum, where the tire takes shape. The green tire is then placed in a curing press, where it undergoes vulcanization, a heat process that gives the tire its final strength and flexibility. After curing, each tire is thoroughly inspected for defects and undergoes rigorous testing before being dispatched. The result? A high-performance tire ready to hit the road. Witness the remarkable journey of a steel billet transforming into a high-tech seamless pipe. The video showcases the advanced process at voestalpine Tubulars, where they manufacture seamless tubular products with unmatched durability and low life cycle costs. Starting with a massive round steel billet, they employ a precise three-step forming process: the cross-roll piercer, push bench, and stretch-reducing mill. At first, the billet is heated to over 1,280 degrees Celsius in an automated rotary hearth furnace, before being pierced by the D-sharp piercing mill, creating a tube shell. Mandrel bars are inserted into these shells, elongating them up to 17 times their original length. This forms a hollow tube, which moves through the stretch-reducing mill, where its final dimensions are achieved. Continuous quality checks, including radiometric gauges, ensure precise wall thicknesses across the entire tube. After the tubes cool, they are cut to final lengths and subjected to additional testing, such as ultrasonic and electromagnetic inspections, to guarantee quality. For specialized uses, the tubes may undergo further processing, including threading and upset forging for oil and gas industry requirements. The final product is subjected to a series of rigorous testing procedures to confirm its performance and reliability. These include hydrostatic pressure testing to ensure the integrity of the tube under pressure and corrosion resistance testing to meet the highest environmental standards. For specific applications, such as in the energy sector, the pipes are coated with corrosion-resistant materials, offering additional protection against harsh environments. The tubes are then prepared for shipment, ensuring proper packaging to prevent damage during transportation. With the highest standards of precision and durability, these seamless pipes meet the toughest demands in various industries, from automotive to energy. The result? A seamless pipe ready for shipment, meeting rigorous standards for commercial vehicles, boiler pressure systems, and even deep-sea oil extraction. All of this, thanks to state-of-the-art technology and rigorous quality control, ensuring every tube meets the highest standards of excellence. 18. Ever wondered how a high-performance carbon fiber wheel is made? Let's take a look inside the XC-Man Carbon Fiber Wheels factory, where cutting-edge technology and precision engineering come together to craft the ultimate wheels for your ride. The process begins with the careful cutting of carbon fabric, which is the foundation of every wheel. The carbon fabric is thoroughly prepared and arranged in pre-built rim straps, ensuring optimal strength and durability. Brake ribbons are also pre-built and placed in the assembly to guarantee the wheel's performance under intense braking conditions. Next, the semi-finished product is placed into a mold, where the combination of heat and pressure works its magic. The molding process is conducted under a membrane pressure system, with temperatures reaching 180 degrees Celsius to 190 degrees Celsius for 1 hour. Afterward, the wheel cools for 15 minutes, completing the curing process and solidifying the structure. Once the wheel has set, it undergoes drilling for spoke holes, ensuring precision and the perfect fit. The wheel is then tested for roundness and flatness to ensure it meets the highest standards of quality. To further validate its performance, the wheel undergoes rigorous mechanical fatigue and crash tests, simulating real-world conditions to ensure its reliability and safety. Every step in the production process is essential to achieving the highest level of performance and quality. With cutting-edge materials and techniques, these wheels are ready for even the most demanding terrains. This detailed process results in a high-performance carbon fiber wheel ready to withstand the toughest challenges. TMK is a global leader in steel pipe production, specializing in oil and gas industry solutions. Large diameter pipes are produced at the volume pipe plant and S-tube works, with an annual capacity of 1 million tons. TMK is the only producer of large diameter spiral pipes in Russia and the only facility globally with specialized heat treatment equipment for these pipes. The submerged arc welding mill produces spiral pipes from 530 mm to 1,420 mm in diameter and 6 mm to 60 mm in thickness. The longitudinal pipe mill, with an annual capacity of 650,000 tons, manufactures pipes from 8 mm to 1,420 mm in diameter. Heat treatment enhances pipe properties, making them comparable to seamless pipes. Pipes undergo non-destructive testing and are coated for corrosion resistance. In this video, we demonstrate the installation process of PERC pipe systems. The first step involves identifying the locations on the pipe where holes are required. Once marked, a specialized drilling tool is used to create holes at the designated points. After the holes are drilled, the necessary connectors are attached, ensuring the system is ready for use. This method is efficient and ensures that the installation process is precise and secure. The installation is then carefully tested for leaks and functionality. All components are inspected to meet the required standards. Finally, the system is sealed and ready for operation, providing a reliable and durable pipeline solution. Welcome to the Yorkville Sound Factory Tour, where an exclusive look inside the manufacturing and distribution facility in Pickering, Ontario, Canada, awaits. Founded in 1963, Yorkville Sound is a top manufacturer of branded PA loudspeakers, Trainer instrument amplifiers, and VTC Pro audio touring systems. This 150,000 square feet facility employs over 250 skilled individuals, all dedicated to bringing these high-quality products to life. The tour starts in the woodshop, where computer-controlled routers precision-cut the wood components for solid plywood cabinet construction. These parts are then assembled using precision jigs to ensure perfect alignment. High-tensile glue is applied, and brad nails are added to secure the joints as the glue sets. Baltic birch plywood is primarily used for its strength and durability, though lighter materials like poplar or fir are selected for certain products that require a more resonant design. Once the cabinets are assembled, they undergo sanding and sealing, with any imperfections filled and smoothed before painting. The painting process is carried out with great care, using eco-friendly paints and glues to minimize environmental impact. Skilled technicians hand paint each cabinet, paying attention to detail. After the paint dries, the cabinets are moved to the finishing line, where all the components are installed, completing the speaker assembly. In the metal shop, all the essential metal components, such as amplifier chassis and speaker grills, are fabricated. Computer-controlled presses are used to ensure precise cutting and shaping. Afterward, the components are powder-coated for extra durability and rust resistance. Additionally, in-house badge fabrication and chassis screening are completed, helping streamline production. The next stop is the electronics assembly area, where vital components like amplifiers, mixers, and signal processors are manufactured. Both surface mount technology, SMT, and through-hole components are used for dependable, long-lasting performance. Each circuit board undergoes a wave soldering process, followed by rigorous testing to ensure they meet design specifications. After the electronics are integrated into the cabinets, the final assembly begins. Each unit undergoes a comprehensive functionality test, followed by a burn-in process. Once the product passes these checks, a thorough QC inspection is performed, including a precision audio test to verify that the speaker performs to specification. Only after successfully passing these tests is the product assigned a serial number and prepared for shipping. Finally, products are carefully packaged and shipped from the climate-controlled warehouse to customers around the world. All Yorkville products are engineered and tested in-house, with the acoustically treated speaker lab at the core of the design process, ensuring superior sound quality every time. Step into the world of large-scale metal forming with the 2,000-ton x 15-meter tandem press brakes. Designed for both single and synchronized operations, these hydraulic machines bend massive metal sheets with unmatched accuracy. Whether used individually or in tandem, they offer exceptional flexibility and power, making them essential for high-capacity industrial fabrication. Every bend is controlled with exact standards to meet the toughest engineering demands. Ever wondered how large-scale steel constructions come to life? At Stalcon, experts in manufacturing and assembly specialize in creating customized steel structures tailored to specific needs. From lightweight cranes to heavy-duty industrial installations, they handle a range of projects, including tanks, silos, pipelines, and large-scale frameworks. The production process begins with precise design and engineering, followed by the careful fabrication of steel components. These components are then assembled into complex structures, such as overhead cranes, harbor devices, and industrial halls. One key aspect of our operations is providing expert assistance during the no-load commissioning phase, ensuring that each construction is tested and calibrated for optimal performance. Through cutting-edge technology and skilled craftsmanship, Stalcon delivers durable, high-quality steel constructions for diverse industries, from power stations to cement plants. In heavy manufacturing, precision and strength are paramount, and CIM Tech's OT forming press ensures both. This 3,000-ton press is designed for the production of tank heads, dish heads, and vessels, a critical component in industries such as petrochemical and pressure vessels. The process begins by heating the raw material to high temperatures to enhance its malleability. The material is then placed into the press, which applies immense pressure to shape the tank head or vessel to exact specifications. The HOT forming process allows for superior strength and uniformity, ensuring each component meets the rigorous demands of its application. CIM Tech's advanced technology guarantees a flawless result, with precise shaping and a smooth finish. This process is ideal for creating components that require high strength and durability, such as pressure vessels used in the energy sector. With its cutting-edge capabilities, the HOT forming press ensures optimal performance and reliability in high-demand manufacturing environments. Have you ever wondered how Toyota manufactures its cars? This video offers a deep dive into the care and craftsmanship that goes into every vehicle through Toyota's comprehensive manufacturing process. From stamping steel plates into parts, applying 1,600 tons of pressure, to the welding process where 4,000 spots are welded, every detail matters. After the body is painted with layers of rust-resistant paint, sealer, and top coatings, it moves to assembly, where over 3,000 parts are installed. With precision checks and rigorous inspections at every stage, Toyota ensures the highest quality. Each car that rolls off the production line is carefully inspected to meet strict standards, confirming there are no flaws, oil leaks, or defects, and only after passing this process is the car delivered to customers worldwide. The attention to detail and craftsmanship that goes into each vehicle showcases Toyota's commitment to excellence. This approach guarantees that every car is not just a product, but a masterpiece built to last. Discover the precision and expertise behind Wyckoff's mechanical gearboxes in this comprehensive production process. As a leading manufacturer of mechanical gearboxes and gears, Wyckoff Group operates from its manufacturing plants in the heart of Europe. The production cycle begins with thoroughly selecting high-quality materials, followed by heat treatment and laboratory tests to ensure optimal performance. The gears are then ground and undergo a series of strict quality controls, including teeth profile inspection, ultrasonic tests for undersurface cracks, and MPI for surface cracks detection. Once the individual components are perfected, They are assembled into the final gearbox, ready for technically demanding sectors. The process includes load testing to simulate real operating conditions, ensuring the durability and exceptional reliability of the final product. With patented solutions and cutting-edge technologies, Wyckoff delivers gearboxes that meet the highest standards of performance, efficiency, and reliability. Continuous control of key parameters throughout the production ensures that every gearbox meets the most stringent requirements, backed by an efficient testing system and dedicated project teams focused on delivering the best to customers. Every stage of production is handled with precision and attention to detail, ensuring the highest quality standards. Advanced machinery and expert teams work seamlessly to achieve exceptional results. The use of modern technologies ensures that each gearbox is crafted to perfection, offering unmatched performance. This commitment to excellence guarantees that Wyckoff's gearboxes stand at the forefront of mechanical engineering innovation. Discover the advanced techniques of turning and milling in this detailed video. The process begins with graphics-based cycle programming, followed by the roughing cycle and program simulation to ensure optimal results. Tool changes occur during horizontal and vertical milling, including milling from the center and thread cutting. Operations like longitudinal turning, square milling with a keyway cutter, vertical slot milling, and hole milling are all performed with high precision. Internal threading and square pocket milling are also key steps in the process. All transitions are seamlessly carried out in one setup, using 4 coordinates. 3 linear motions for the tool, and 1 rotational motion for the workpiece, ensuring efficiency and accuracy at every stage. Unveil the production process behind 18 Sound, Italy's leader in loudspeaker technology. The process begins with the design phase, where engineers create detailed prototypes and conduct simulations. Once the design is finalized, raw materials are carefully ground and molded into components. These parts are subjected to extensive testing, including power and endurance tests, to ensure they meet performance standards. The manufacturing process combines robotic precision with the expertise of skilled technicians, ensuring every loudspeaker is crafted to perfection. Throughout production, strict quality control checks are performed to guarantee good durability and exceptional sound performance. Welcome to the MAN PrimeServe Hamburg Workshop, a leader in engine technology with over 70 years of expertise. Here, engines are thoroughly repaired and reconditioned using state-of-the-art equipment. From grinding crankshafts to machining complex parts like piston crowns, every process ensures precision. The use of laser viewing technology and tailored solutions for components like cooling pipes showcases PrimeServe Hamburg's commitment to quality and environmental care. Discover the versatility of Dormer Pramit tooling in this comprehensive demonstration video. Watch as 16 different operations are carried out using both indexable and round tools. The processes include face turning, drilling with internal cooling, countersinking, profile grooving, milling, parting off, and engraving. Each operation, such as turning, drilling, and milling, is performed with precision, with special attention to cooling in critical areas like parting off and drilling. The workpiece material is C45 steel, DIN 12050, with a hardness of 170 to 180 HB. The machine used is the Mazak QT Compact 200 MSYL. See how these tools deliver reliable, high-quality results across various applications like profile roughing, turning, and engraving logos. This video highlights the efficiency and reliability of Dormer Primet tooling for demanding machining tasks. Discover the world of Colossi, a global leader in die-casting machines. This video showcases Colossio's cutting-edge processes and innovations. With expertise in hot chamber systems, fully equipped working cells, and advanced mechanical engineering, the company leads in customization. Their internal machining and assembly departments ensure top quality, while energy-saving technologies reduce consumption by up to 80%. Colossio SRL stands out for its technical knowledge, professionalism, and commitment to excellence in die-casting manufacturing. Watch the powerful journey of how a wheel disc is made. To ensure maximum durability, each wheel is carved from a solid aluminum piece, preventing any breakage. A diamond-coated cutter shapes the aluminum, then the blanks are heated to 500 degrees Celsius for 2 hours in an oven. The softened material is then formed into a disc under 4,000 tons of pressure. This process aligns the aluminum molecules, creating strength. After cooling, the disc is shaped into its final form. The wheels are polished and undergo rigorous testing to ensure they're perfectly round. Finally, they are ready to hit the roads. Uncover the gold refinement process at Aldongo in Rwanda, where raw gold is expertly melted, analyzed, and purified using cutting-edge technology. The gold is first melted, sampled, and tested for purity. Through a chemical process with aqua regia, impurities are removed, leaving 99.99% pure gold. Aldongo can produce up to 240 kilograms of gold daily, molding it into various weights like 1 kilogram, 500 gram, and 100 gram bars. Experience the craftsmanship behind ASO Forge's special steel bars, where accuracy and strength are seamlessly integrated at every stage. The process begins with advanced furnaces that heat the steel to the perfect temperature, followed by the powerful force of a 5,000-ton press, shaping it into high-performance bars. Integrated manipulators ensure smooth handling, while terminal treatment furnaces enhance the material's durability. The company's steel products excel in the most demanding applications, from automotive to construction. Each steel bar undergoes thorough testing to guarantee its reliability under extreme conditions, with performance optimized for strength and resilience. By constantly pushing the boundaries of innovation, the company maintains its commitment to quality, ensuring their products meet the highest standards of strength, reliability, and longevity.